Aloha everyone. So for today's lecture video, we'll be discussing about estimation of parameters. Let's begin. Learning objectives at the end of the discussion, we're expected to number one, discuss the concept of estimation, two, differentiate point estimate and interval estimate, three, identify the properties of point estimator, 4. Determine the value of level of confidence and level of significance. 5. Compute the letter A point estimate of the parameters, B standard error of the mean, and C margin of error. 6. Use the Z and the T distribution table in computing the margin of error. 7. Find the confidence intervals of the population mean when the population standard deviation is known using T distribution table and when the population standard is unknown using T distribution. Number 8, compute the letter A proportion estimate of the parameters, B standard error of the proportion, C margin of error of the proportion. 9, find the confidence interval of the population proportion when the sample proportion is known. 10, solve problems involving confidence interval estimation of the population proportion. 11, compute for an appropriate sample size using the length of the interval. And number 12, solve problems involving sample size determination. Now, as you can see, we have a lot of things to discuss. So I'll be cutting our discussions into three parts. The first will be for the concepts of estimations and the Z distribution. Second will be for T distribution. And the last is for proportion, population proportion. Let's start with the concepts of estimation. So let's define first what is an estimation. So estimation refers to the process by which one makes inferences about the population based on the information obtained from a sample. Also, its concern is to find the value or range of values of an unknown parameter. Now, in our previous discussion, we have discussed sample distribution and probability distribution. And we have learned that sample statistics is generated through sample surveys. And from that sample surveys, we can already make an inferences of the characteristics of the population. If you can still remember the cycle, we have the population, and then we have the sampling method wherein that is the process in generating a sample and from that sample performing some statistical process or or testing, we can already make an inferences of the characteristics of the entire population. So one of the process that I'm talking about in making an inferences of the population is what called an estimation. Okay, so we have an estimation and the hypothesis testing. That are the two ways in making an inferences of the characteristics of the entire population. So we will now focus more on estimation and parameters. All right. So we also have here what we call the estimator and the estimate. Estimator is a mathematical expression or formula used in coming up with the estimate. An estimate arrive numerical value after applying the estimator. Now, like for example, class, you need to guess the age of your teacher, your statistic teacher. Okay, so that is your task. And you are given a chance to ask one question to come up with the correct answer. So probably the question that you will throw is that what is the birthday of your teacher for you to determine the the present age of your subject teacher. Okay, so why did you, well if you will notice that is the question that can answer the question, right? Like because you will perform an operation wherein you will subtract the birth year to the present or to the current year. Like for example, my birth year, or yes, my birth year is 1994. So you will subtract it to the current year. So you will arrive with an answer that is 27. So that operation or that formula is what we call an estimator, and the answer that you get using that estimator is what we call estimate. Okay, so I hope that um, the difference between the two is clear. Okay, so let's proceed. Point estimator. So it is point estimator. It's a numerical value, and it identifies a location or position and the distribution of possible values. It is a specific numerical value estimate of a parameter. So we only have two possibilities here. It's either your estimate is correct or wrong. Since again, you will only have you have here for point estimator, you only have here a specific numerical value estimate of a parameter. All right. So next, so let's have an example. So 50 kilograms is the average weight of the sample of 10 students randomly drawn from a class of 100 students. What is the best point estimate of the population? Now, class, please take note that the best point estimate that we are talking about here is the sample mean value itself. So again, if you are asked to find the point estimate, all you need to do, class, is to find the sample mean. Now, on this given example, 50 kilogram is the average weight of the sample of the 10 students. That is randomly drawn from a class of 100 students. So on this given example, 50 kilograms is the sample mean. Thus, it is estimates that the average weight of the entire class is 50 kilograms. So the best point estimate is 50 kilograms. So let me repeat again. The best point estimate is the sample mean value itself. Another example. So 55 is the mean mark obtained by a sample of 5 students randomly drawn from a class of 100 students. What is the best point estimate of the population? Right? So again, all you need to do is look for the sample mean on the problem. So the sample mean here is 55, hence it estimates that the mean mark obtained by the entire class is 55. So again, for this given example, the best point estimate is 55. Next, properties of good estimator. The first property is the estimator should be an unbiased estimator. So meaning to say the expected value or the mean of the estimates obtained from samples of a given size is equal to the parameter being estimated. So like for example, you have an infinite samples, and then you are tasked to find the sample mean of each sample samples. Then if the sample mean is equal to the parameter being estimated, we can say that the estimator is unbiased. Next, the estimator should be consistent. As the sample size increases, the value of the estimator approaches the value of the parameter estimated. So meaning to say the maximum error of difference from using the estimator is very small, so that we can say that it is consistent, or the your estimate is very close to the parameter being estimated. All right, next. The estimator should be relatively efficient estimator. Of all the statistics that can be used to estimate a parameter, the relatively efficient estimator has the smallest variance. Okay. Now, the same with consistent and unbiased. Okay, all you need to do is look for a relatively efficient estimator. So basically, The relatively efficient estimator has the smallest variance or dispersion. So again, we have here three properties of good estimator. The first is the good estimator should be unbiased estimator. The second, the estimator should be consistent. And the last is the estimator should be a relatively efficient estimator. All right, next. Interval estimator. So it describes a range of values bounded by the lower limit and upper limit within which a population parameter lies using a predetermined degree of confidence. So the that is for the interval estimator. All right, so let's have an activity. So like for example, again, you need to guess the age of um father principal. Okay, so you need to guess the age of father principal in in range. Like like you have a lower limit and an upper limit. So for example, your guess is around 35 to 60 years old. So that is your guess of the age of of father principal. Okay, so that is what we call an interval estimate. Your answer is what we call interval estimate, and the process of coming up with an interval estimate is what we call an interval estimator. Like you need to consider the legal age, for example, of what is the legal age of um the legal age of having a work as a principal. What is the legal age for that? So that would be your lower limit, and what will be the retirement for being a father principal. So that would be your upper limit. So the process that you did, okay, in order for you to come up with the upper and the lower limit is what we call the interval estimator, and your answer for that is what we call interval estimate. Now, for example, your confidence level, on the other hand, is the probability that the interval estimate will contain the parameter, assuming that a large number of samples are selected and that the estimation process on the same parameter is repeated. It is the measure of confidence in the interval estimated. So when we say confidence level, this is the confidence that you put on the interval estimate. Like for example, I am I am 95% confidence that the age of father principal will fall within 30 to 60 years old. Okay, so that is confidence level. So again, it is the measure of confidence in the interval estimate. Confidence interval. Confidence interval is a specific interval estimate of a parameter determined by using data obtained from a sample and by using the specific confidence level of the estimate. So we have a formula for confidence interval. So this is now the combination of the interval estimate. This is now the combination of the interval estimate and the confidence level. So we have here four most likely used confidence level and its corresponding z values. So we have here the 90, the 95, the 98, and the 99% confidence level. So when we say alpha, that is the total area of the tail. Again, let me repeat. Area alpha stands for the total area of the tail. Now, if your alpha is 0.10, meaning to say that the confidence level is 90%. And if your alpha is 0.05, the confidence level is 95%. Your alpha is 0.02, the confidence level is 98%. And if your alpha is 0.01, the confidence level is 99%. So you can also call alpha as level of significance. Okay? So alpha um, also can be represented by, you can also call alpha as significance level. So the significance level of alpha is 0.10. Okay? And as you all know that the area of the normal curve is equal to 1. So 1 minus the total area of the tail. So 1 minus 0.10, so that's 0.90. That's why we have 90%. Alpha, 1 minus 0.5%. 1 minus 0.02, that's 0.98 or 98%. And 1 minus 0.01, so that is 0.9, 0.99 or 99%. Now we have here alpha over 2, meaning to say you divide detail into two parts, the left and the right tail. Now, alpha divided by 2 for 90% confidence level, that's 0.05. For 95%, 0.025. For 98%, that's 0.01. And 99% confidence level, alpha over 2 is 0.005. Now we have here, this is very important in solving a confidence interval. We have here the Z alpha over 2. Now, the Z alpha over 2 for 90% confidence level is 1.645. The confidence level for 95% is 1.96. And the confidence level for 90% is 2.30. And the last is the confidence level for 99% is 2.575. So you need to memorize this Z values because this is important in solving the confidence interval. Okay. So again, this is the four most likely used confidence level and its corresponding Z values. Um, you can also find this table on your reading material. Now, how did you come up with 1.645 for the 90% confidence level? So I'll show you the solution on how to find the Z alpha over 2 of a given confidence level. Now, for this given example, our confidence level is 90%. So how can we find the Z alpha over 2 for 90%? And we know for a fact that it's 1.645. So let's find out how did we come up with 1.645. So the first thing that you need to do is you need to find the alpha. So the alpha for the 90% confidence level is zero point 0.1 or zero point 0.10. Second step is you need to find the value for the alpha over 2. And the value for that is 0.05. Now you try to sketch that in a normal curve. So you will have this. You will have this illustration. Now, um, your um, your task here is to know the area starting from the mean to the black line or the black boundaries of the normal curve. So again, starting from the mean up until the black line or the boundaries, what is that area? So that is the thing that you need to do. Now, that's why we get the alpha over 2 so that we can subtract this to zero point 0.5. So we will subtract zero point 0.05 to zero point 0.5, and that is the area starting from the mean up until the black, or for starting from the mean up until the boundaries. Okay, so to show you an illustration, again, we know for a fact that they are symmetric to each other. For one property of the normal curve, they are symmetric to each other. Now, starting from the mean to the right, we can have an example to the right, starting from mean to the right. So this is 0.4500 because the total area of the half of the normal curve is zero point 0.5. So all we need to do is subtract the right tail to zero point 0.5. So we will have 0.05, 0.5 minus 0.05, so that is 0.4500. So this is the z value that we need to locate using the z table. So again, please get your z table and please check what is the closest area to 0.4500. So if you will check it, the closest area to 0.4500 is 0.4495 and 0.45. Okay, so both of them are closest to 0.4500. So we will have here the z-scores, that is 1.64 and 1.65. So since we have two z-scores here, what we're going to do is we need to get the average. So the average of this is 1.645. That's why we come up with an answer for the 90% confidence level. The z value is 1.645. Okay, so that is the process of getting the z values for a given confidence level. Okay. Now, for example, you are tasked to find the 94% confidence level. Okay? So that is not part of the table that we just presented, or that is not part of the most likely used confidence level. Like for example, you are tasked to find the Z alpha over 2 for 94% confidence level. So the first thing that you need to do again is you need to know the alpha. What is the alpha of the 94%? The 94% confidence level for 94%. So that is 0.06. The second step is you need to know the value of the right and the left tail, because you will use that, okay, in order for you to know the area. So that would be the 0.06 divided by 2, so that is 0.03. So that is the area per each tail. So instead of 0.05, we have here 0.03. Okay. Now, what we're going to do is we will subtract zero point zero 0.03 to zero point 0.5. So we will have zero point 0.5 minus 0.03. So that would be 0.4700. So ito yung gagamitin natin to find, okay, ito yung gagamitin natin na area to find the z-score, okay, in order for us to know the z values for that specific confidence level. So 0.4700, using the using the standard normal table, you can see that the closest here is 0.4699. So that is the closest. So the z-score for that is 1.88. So that is the closest. It's not 0.4706 because again, we only have here one difference for you to have 0.4700. So again, we will choose the closest z-score, and that is 1.88. So therefore, the z value for the confidence level 94% is 1.88. So you can add that on your table, that the z value for z alpha over 2 for 94% confidence level is 1.88. Okay, next. Interval estimate. Interval estimate, it is a range of values where most likely the true value will fall. So we have here the formula. point estimate plus or minus margin of error. So for the lower limit, so we have your point estimate minus margin of error. For the upper limit, we have point estimate plus margin of error. All right, now let's have an example here to better understand point estimate, interval estimate rather. So the mean monthly allowance of business administration students is 3,500. If the precision of the estimate 3,500 is plus or minus 500 pesos, the monthly allowance for a certain student could be as low as 3,000 and as high as 4,000 pesos. All right. So again, the lower limit we have here is 3,000 and the upper limit we have here is 4,000. Why is it? Because the sample mean is, or the point estimate here is 3,500, and the margin of error that we are talking about is 500 pesos. So for the lower limit, the computation is that point estimate minus the margin of error. So 3,500 minus 500, so that is 3,000. And for the upper limit, that is point estimate plus margin of error. So 3,500 plus 500 pesos. So that is 4,000 pesos. So again, the interval estimate is between 3,000 and 4,000 pesos. Next, what if the precision is plus or minus of 100 pesos? So again, the margin of error that we're talking about here is 100 pesos. So the same point estimate or the same sample mean. So we have here 3,500. Therefore, the interval estimate here is between 3,400 and 3,600. So again, the formula, point estimate minus plus margin of error. So for the lower limit, 3,500 minus 100, so that's 3,400. And for the upper limit, so that's 3,500 plus 100, so that's 3,600. So the interval estimate again is between 3,400 and 3,600. All right, so I hope that it's clear. Next, interval estimate of the population mean with known standard population standard deviation. All right, so we have here the formula for the confidence interval of the mean for a specific population standard deviation. So we will use this formula if and only if the population standard deviation is known and the sample size is greater than or equal to 30. So again, we will use this formula if and only if the population standard deviation is known and the sample size is greater than or equal to 30. So we have here the formula x with a bar on top minus z alpha over 2 times sigma all over square root of n. This is our lower limit. And for the upper limit, we have x with a bar on top plus z alpha over 2 times the quantity sigma over square root of n. So x with the bar on top, this is the sample mean or the uh, best point of estimate. The z alpha over 2, again, we have the four most likely used confidence level. So we have 1.645, 1.96, 2.33, and 2.575 for the 90, 95, 98, 99% respectively confidence level. Sigma is the population standard deviation, and N here is the sample size. Now we have here the formula for the standard error of the mean. Now the formula we have for the standard error of the mean is sigma all over square root of N. Okay, so please take note that please take down the nearest hundreds. All right, sorry, I'm lost. Okay, so going back, so we have here the correction factor for normal distribution. We have here all maximum error of estimate or the maximum error of difference. So we have here z alpha over 2 times the quantity sigma all over square root of n. So same with the standard error of the mean, please round off your final answer to nearest hundreds. Okay, next, we have here the maximum error of difference. So maximum error of difference, it is the maximum likely difference between point estimate of parameter and the actual value of the parameter. Okay. So again, class, we have here the most likely used confidence level and its corresponding z alpha over 2. Please take note. Please remember this. Okay. This is very important in solving the confidence interval. Okay. The rounding rule for a confidence interval for a mean. Okay. So the rounding rule for a confidence interval for the mean. So when you are computing a confidence interval for a population mean by using raw data, round off to one more decimal place than the number of the decimal places in the original data. Okay. So meaning to say, class, if you have a raw data presented, you need to add one more decimal place to the original data. Meaning to say, if your data is in a whole number, you need to add one more decimal. Therefore, your final answer should be in the nearest tenths. If your data is in nearest tenths, then you need to round off your final answer to nearest hundreds. Okay, so that is if you are presented by a raw data. Next, when you are computing a confidence interval for a population mean by using sample mean and standard deviation, round off to the same number of decimal places as given for the mean. So if the sample mean and standard deviation is given, then the same number of decimal places as for the mean. So if it's whole number, if the sample mean is in whole number, your final answer should be in whole number as well. Okay, so that's the difference between the two. And that is the rounding rule we have for confidence interval for n. Please take note of this. This is very important. If you will not apply the rounding rule on your final answer, of course, that will result to an incorrect answer. Okay, so let's have this example. Example number 4, I randomly selected 80 scores from the scores of students enrolled in statistics class that is normally distributed with a standard deviation of 10. Have a sample mean of 85. What is the point estimate of the population mean? Compute the standard error of the mean. Find the 95% confidence interval of the population mean. Okay. So for the point estimate of the population mean, again, that is just the sample mean value. So on this given example, the sample mean value is 85. Okay, so the sample mean here is 85. So that is the best point estimate of the population mean. So that is the answer for number 1. Now compute the standard error of the mean. So for number 2, so we have here the formula for the standard error of the mean. So we have here sigma all over square root of n, and the standard deviation on the given problem is 10, and our sample size is 80. So we have here 10 over square root of 80, so that is approximately 1.12. So again, we apply here the rounding rule that It should be rounded off to the nearest hundreds. Now let's proceed with the 95% confidence interval of the population mean. Now, for us to solve this, we need to know first the Z alpha over 2 for the 95% confidence level. And that is on your table, the Z alpha over 2 for the 95% confidence level is 1.96. Thus, we have here the following given. So, x with the bar on top or the sample mean is 85. The z alpha over 2 is 1.96. The sigma or the population standard deviation is 10 and our sample size is 80. As you can see, it satisfies the conditions that the population standard deviation is known and the sample size is greater than or equal to 30. So check siya. So we will now use this formula. So this is what we call the Z distribution. Okay? So all we need to do is substitute again the given to our formula. So we will have 80 minus 1.96 times the quantity 10 over square root of 80. Okay? That is for the lower limit. And for the upper limit, 85 plus 1.96 times the quantity 10 over square root of 80. Now, we will have here, using your calculator, you will have here 82.81 for the approximately 82.81 for the lower limit and 87.19 for the upper limit. Now, we will now apply, this is not yet the final answer. We will apply here the rounding rule for the confidence interval. So since our mean is in a whole number, our final answer should be in a whole number then. Therefore, the final answer should be between 83 and 87. So one can say with 95% confidence, the true mean of the population is between 83 and 87. Okay, next. Example number 5. The average grade of 100 randomly selected grade 11 students of University X, XZY is 89 and its population standard deviation is 11. Find the 90% confidence interval of the average grade of the entire grade 11 students. So before we proceed with finding the 90% confidence interval, what is first the best point estimate here? So again, that is just the sample mean value, and that is 9. So the sample mean or the x with the bar on top is 89. Next, it's what is the 90% confidence level? So the 90% confidence level or the Z alpha over 2 of a 90% confidence level is 1.645. So we will have the following given. Have x with a bar on top or the sample mean that is 89 plus alpha. The standard deviation is equal to 11 and our n is 100. So again, the population standard deviation is known and the sample size is greater than 30. So we will now use here the Z distribution or this formula. So again, substitute. So we will have 89 let me repeat. So we have here 89 minus 1.645 times the quantity 11 over square root of 100. That is for the lower limit. And for the upper limit, we have 89 plus 1.645 times the quantity 11 over square root of 100. Okay? Now, using your calculator, you will arrive with an answer approximately 87.19 and 90.81 for the upper limit. Now we will, again, it's not yet the final answer because we will apply the rounding rule. If this is your final answer, then your answer will be incorrect. So applying the rounding rule, since our sample mean is in a whole number, so our final answer should be in a whole number as well. So it should be 87 and 91, between 87 and 91. Thus, one can say with 90% confidence the true mean of the population is between 87 and 91. Okay, so let's proceed. Another example. Example number 6. So a researcher wishes to estimate the average amount of money a person spends on lottery tickets each month. A sample of 50 people who played the lottery found the mean to be 950 and the standard deviation to be 150. Find the 95% confidence interval of the population mean. All right, so first, what is the best point estimate here? So again, that's the sample point or the sample mean value. And the sample mean value here on our example number 6 is 950 pesos. Thus, the best point estimate is 950. Next, find the 95% confidence interval of the population mean. We need first to know the Z alpha over 2 or the Z value for the 95% confidence level. And that is 1.96 using the table. So thus we will have the following given. X with the bar on top, that is the sample mean is 950, the Z alpha over 2 is equal to 1.96, the standard deviation is 150, and our sample size is 50. So the conditions are satisfied. We have here the population standard deviation and the sample size is greater than 30. So we will now again use this formula. Okay? So for this formula, we have x with the bar on top minus x, the z alpha over 2 times the quantity sigma over square root of n for the lower limit. And for the upper limit, so we have x with the bar on top plus z alpha over 2 times the quantity sigma over square root of n. So again, substitute. We already have all the given. Substitute lang and then use your calculator to compute. So you will have approximately, so you have approximately 908.42 for the lower limit and 991.58 on the upper limit. So again, our sample mean is in whole number. Therefore, our final answer should be in whole number as well. Therefore, okay, so therefore, the 95% confidence level of the mean have the lower end of the interval of 908 pesos and the upper end of 992 pesos. So it's very easy. Ano? All you need to do is find the Z alpha over 2 of the given confidence level. You just need to know whether it satisfies the condition in using the formula for the Z distribution. Then substitute if it satisfies. Then apply the rounding rule. So that would be it. All right. So last example. So we have your last example. Okay, a survey of 30 adults found that the mean age of a person's primary vehicle is 5.6 years. Assume that the standard deviation is 0.8 year. Find the best point estimate of the population mean and the 99% confidence interval of the population mean. Now, first is the best point estimate. It's very easy. Again, it's the sample mean value. And the sample mean value on this given example is 5.6 years. So this is now our best point, the best point estimate of the population. Next, the 99% confidence interval of the population mean. First, we need to know the Z alpha over 2 for the 99% confidence level. And that is 2.575. Therefore, we will have the following given. So for the x with the bar on top or the sample mean, we have 5.6. The Z alpha over 2 for 99% confidence level is 2.575, and the population standard deviation is zero point 0.8, and the sample size is 30. Now, it still satisfies the condition we have in using the z distribution formula, or this formula. So we will use this because the population standard deviation is known and our sample size is equal to 30. Okay? So again, substitute lang natin sa ating formula. So we will have 5.6 minus 2.575 times the quantity 0.8 over square root of 30. That's for the lower limit. And for the upper limit, 5.6 plus 2.575 times the quantity 0.8 over square root of 30. Okay. Now, using your calculator, you will arrive at approximately 5.22 for the lower, and for the upper, we have 5.98. So as you can see, class, our sample mean is in tenths. Okay, it's not in a whole number, so it's in tenths. So therefore, our final answer should be rounded off into the nearest tenths as well. So our final answer here is 5.2 and 6. Therefore, the 99% confidence level of the mean have the lower end of the interval of 5.2 years and the upper end of 6 years. Okay, so that would be for the first part of our lecture video.